Now say that again.
25 subtract B.
Okay, now look at what it says here. 25 less than a number B. You said this, 25 subtract B. Not the same thing. Not going to work. I want 25 less than the number B. What am I going to write, Josie?
B subtract 25.
There we go. B minus 25. See how this reads, Chloe? This is now 25 less taken away from the B. Okay? This is the only time that you do it in reverse order. When you see the words less than, you always put this one first and this second. Okay? Always on a less than statement. A number x divided by 4. A number x divided by 4. Chance.
X divided by 4.
I'm going to start doing my x divided by like that all the time because I want you to see a fraction is a division statement. Good. Number 5, the total of a number t and 11. How am I going to write that one, Roper?
T plus 11.
Good. Notice my t, I kind of changed the way that I write it so you don't see it as plus 11 because that would not be right, right?
Yeah.
Finally, 100 decreased by a number k. 100 decreased by a number k.
K minus 100.
Okay, here's what I heard. You said k minus 100. What's being decreased there? K is, right? So that doesn't work. So how do I write that one? 100 decreased by k. Jaslyn.
100 minus K.
Good. Okay? The only one you have to go to the back first is if it says less than. A number, something less than a number. Okay, then you go and it's in reverse order. But otherwise, it's pretty much the order that it's given. Okay? Any questions there? Okay, let me get this where we can see it because it's still not letting me. I don't know why it all of a sudden isn't letting me see everything. Well, can you see it all there? Yeah. Okay. The length of Interstate 90 from the west coast to the east coast is 153.5 miles more than 2 times the length of the Interstate 15 from Southern California to northern Montana. Okay, I'm going to go in right now and I'm going to underline some important things. Is the 90 here important? No, it's just a highway number. Okay, the length of Interstate 90 from the west coast to the east coast is 153 miles. This is pretty important right there. More than 2 times the length of Interstate 15 from Southern California to Montana. Let M be the length of the Interstate 15. Which expression can you use to represent the length of Interstate 90? Okay? Well, 153, and see, I look at it and I write my own statement. Because sometimes the statements they use are similar to mine, but it may be written a little bit different, and that helps me to see it. So for me, I look at this and I say, well, 153 more than 2 times the length of 15, and M is 15, so 2M plus 153.5 is going to give me Interstate 90. Do you agree?
Yeah.
That's the way I would write it. That's just for myself. And then I look and see, well, are there any of them that are exactly the same?
Yeah.
Is there anything there that's exactly the same? And I can pick the answer really quick and easy. Braden. A. I agree. A is my answer. Now, what's wrong with the 100? What's wrong with D? What's wrong with D? Why does it not work? Why is it not going to work? Esri.
Because you're multiplying N by 153 and 510.
yeah. I'm multiplying the length of Interstate 15 times the 100, yeah, that's not even close. But this one is 2M, twice as more of M, but I'm subtracting it from the original. That doesn't work. Yeah, this is the only one that works. Okay? I can't always look at, I've told you guys this before, I'm a doer. I do math. And if I don't do it, physically do it, sometimes I can't do it here. You know, sometimes I can, but I find that I make a lot more errors if I simply do it in my head. I have to put it down. For me, there's something about seeing it and putting it on paper that makes the difference. Okay? Braden?
And it said more than, so like the 2 times was behind more than, so you have to switch it.
Good. More than says I'm going to be adding. That times tells me I got to multiply. So I know I need addition and multiplication, and my statement has both. Okay? These with all this subtraction stuff. Okay? And then I just had to figure out which one was correct. Okay. Got another story problem. And the reason why today we're kind of moving into some story problems is because I looked at your homework from Monday, and you guys did a really good job. And so today we're just going to do a little bit more of the same stuff. And so I figured we'll kind of get ourselves woke up and get it going, and then I'll give you the assignment, and you'll have the rest of the class period to do it, okay? We are still writing mathematical expressions. That's our goal. We still have to be able to do that. You plant a cypress tree that is 10 inches tall. Each year, its height increases by 15. Well, it starts out at 10 inches. That's important. Increase 15. And I need to know that is yearly. Okay, that's kind of important, yearly. Okay? It says make a table that shows the height of the tree for 4 years. Then write an expression for the height after T years, so after however many years. Well, if I make a table, here's my table. Bad table, but we get it, right? Okay, and we know this is height, and this is the years, okay? So what is it when it starts out? What did it tell us?
10 inches.
10 inches to begin with. So at 0 years, it's 10 inches. Do you agree? That's where we started. So how tall is it after it's grown for 1 year? How tall is it going to be at the end of 1 year? How tall, Tyler?
25 inches.
How do you know that, Tyler?
10 plus 15 is 25.
Good. Because it's increasing, which is my addition, 15 inches per year. So that was going to be plus 15. And so it's going to grow, the second year, it's going to grow another 15 inches, right? So how tall is it going to be at the end of the second year, Mr. Jorlin? 40? Do we agree with you guys? I wrote 45. I didn't really need to. Give me a little bit. Third year. How tall is it going to be in the third year? Cadence. Cadence, sorry. 55. What about the fourth year, Ben?
So it'd be 60 plus the other 5, so that'd be 65. Well, no, plus the other 5, that'd be 10, so it'd be 70. Because we would do the 5, that'd be 65 plus 5.
I agree with you. 55, 65 plus 5 more is 70. Okay. So every year, okay, it says then write an expression after T years. So how do I know with T years. What's an expression that I could write? That 100 years from now, I could tell how tall it was gonna be. Am I gonna wanna go 100 times this way? Am I gonna wanna do 5 years, 6 years, 7 years, 8 years, 9 years?
No.
I don't think so.
Oh, no.
So what's an expression, and it's gonna be an algebraic expression, that I can write? What do you think, Jaslyn?
15 times t.
Well, that would tell me every year it grows 15. I agree with that. But is that gonna tell me how tall that tree is?
No.
Alone, would it tell me how tall the tree was?
No.
Cashton?
10 times 15 t.
Well, if that was true, that would be saying 10 times 15t every year. Is that how much it's growing? No. Graydon?
10 plus 15 times t.
There you go. That is absolutely correct, Graydon. Why?
Because on 10 at the beginning it is 10. And then you take it times 10 plus 15 would equal what it is in 1 year. And then you take that 15 times t.
You're
and
right.
then you add that.
You're absolutely right. Remember when we talked about expressions and we said this is what we call the constant? Okay? The reason we call that number right there that has no variable attached to it, that's the constant, because I don't care 100 years from now, it still only started at 10 inches. That's as tall as it was when it began. When we began measuring the growth of this tree. That 10 always has to be there. But every year, it's gonna grow another 15 feet. And so T stands for time. And at 100, let's go, at 100 years old, how tall is that tree gonna, well, I'm not even gonna go there. This says, at 9 years old, how tall is that tree gonna be? And you should have your calculators, because you picked them up on your way in. So at 9 years old, how tall is the tree? Emmy, I'm gonna let you get your, do you need your calculator or you already got it?
Go tell her.
Go get it, kiddo.
Number 5 is gone.
Who's got number 5? 6th graders, you are the absolute only ones that use that calculator. Who's got number 5? Who is number 5? Is that you, Jaslyn? You need to go check in your classroom for it then.
It's right here, Jasmine.
Oh, Jaslyn, there we go.
I got the same exact thing last time. It looks like a 8.
At 9 years old, Emmy, how tall is this tree? How tall is it? 145 inches tall. Absolutely correct. We substituted the 9 for that T, and our expression became 15 times 9 plus 10. Okay? All we do is substitute the value in place of the variable and solve the equation. Okay? Any questions on this? Everybody knows where it's coming from. Everybody has their notes filled out, right, Miss Monique? Got it all filled out? You need to do so. Yes, sir?
The tree would be 12 feet and 1 inch.
Ah, 12 feet and 1 inch. Is he correct? How'd you get it?
Because 12 times 12 is 145.
Very good. 12 times 12 is 144. One left over would be an inch. Very good. Okay. Your friend has 5 more than twice as many game tokens as your sister. Okay, so 5 more twice sister. Just a little note for myself, right? 5 more twice than the sister. Let T be the game tokens your sister has. Well, if I've said twice the sister, I already know I gotta have 2T. Do you agree? Twice the sister. Let T be the number of game tokens your sister has. Write an expression for the number of game tokens your friend has. What's that expression gonna look like? How many more does the friend have? How many more than my sister does my friend have? 5. So what do I do with the 5? It says more. What's the operation I want to use? Monique, what operation is more? Nope. We already did the multiplication. Good try. What operation? Addition. Good. Pretty simple there, right? Are story problems really that hard?
No.
They used to scare the snot out of me. And when I looked at all the words, that's why. I'd get all lost in the words, right?
Yeah, I don't.
When you underline what's important, do the rest of the words just kind of go away? They just kind of blend in the background, and now they're not a big issue anymore. Okay? Your assignment. Right there. Textbook page 122 and 123. 1, 2, 14 through 22 even, and 28 to 32 even. That's it. Other than reminding you again, when is the vocab due?
Friday.
Friday. That is 2 days away, folks. Josie? Do what, honey? No, you don't have 37 problems, not if you think about that. You're only doing half of them.